All right, everybody, we are ready to get started here. Welcome to the Morrison Planetarium. My name is Mary. I'm going to be your presenter today for our tour of the universe. And in this show, we are going to be flying around space together. I'm going to be our pilot as we go throughout the universe. We're going to start out at Earth. We're going to zoom out as far as we can out into space. We'll stop a few places along the way, and we'll come back safely home at the end of the show. And in order for us to do all of this, I do have to head all the way up the stairs to our pilot's booth, which is at the very top of the room up there. And I will be piloting our show today with a free software called OpenSpace, which is free and open source. So if you have a powerful enough computer at home, you can download it at home for free. So let me know if you want to know about that after the show. But as I head up, I do have a few quick planetarium rules to go over. First of all, please no eating or drinking while you're in the planetarium today, mostly to make sure that we keep our seats nice and clean. While you're following that first rule, the next rule should be pretty easy. Make sure to keep that mask on for the entire show. Even once the lights go down, please keep that mask on. If you have a cell phone, a camera, a tablet, anything at all that could give off light or sound, both of those can be pretty distracting in here. And like I mentioned, this is a live show. We don't want to accidentally run into a planet because I'm distracted. So make sure to keep those cell phones put away during the whole show. And for your safety in this dark theater, with these very steep steps we have here, we do highly recommend staying seated throughout the entire show. But if you find that you need to leave early for whatever reason, the exits are at the top of the stairs. And last but not least, this can create a very immersive experience. So if you feel any dizziness, any motion sensitivity, go ahead and close your eyes for a few seconds, and that will help your brain kind of reset and remember you're just sitting in a chair in a planetarium, not actually flying around in space. So without further ado, go ahead and sit back, relax, give me a moment to get into our pilot's booth here, and we will get started. All right, so we are starting our tour of the universe today, relatively close to home, just a few hundred miles above the Earth's surface at the International Space Station. And I always like to start out at the International Space Station because it gives us a little bit of perspective on how incredibly far we're going to go today. Because today we're going to, like I mentioned before, go out as far as we can out into space, as far as we can see in our universe. And along the way, we're going to check in with our human influence out here in space. So we'll see things like how far have human beings traveled? How far have our spacecraft traveled? And how far have anything that we've sent out at all have traveled? And we are going to go much farther than that. But the International Space Station is as far as humans do travel out into space right now. You can fit about 6 or so astronauts on it at any one time. People have been living up there for about 20 years now, but don't worry, it's not the same 20 people that have been stuck up there. They do swap out every few months or so. And the longest that any particular person has lived up there is about a year. And I'm going to bring up a yellow line here so we can keep track of the International Space Station as we zoom away. So that yellow line is to show the orbit of the ISS, where it goes around our planet. And you can see they're moving pretty quickly here. It takes only about 90 minutes for them to orbit us once. And that's another reason why I like to start out here as well, is because we're using OpenSpace, which uses real data and open source software. We are seeing where the International Space Station is right now. So this is where it is right now. So as I zoom away, I'm not very good at geography, but we are near an island of some sort. Let's see if I can figure it out as we zoom farther. And as I zoom farther, we're also seeing some clouds show up and the different features of our lovely planet that we live on, Earth. And these clouds and weather patterns we're seeing are from different satellites that are going around our planet. So we have all sorts of science satellites and robots and things that are flying around our planet all the time and keeping track of things like weather and how the tectonic plates are moving, all sorts of cool stuff. So these are where these clouds and weather patterns were early this morning. But I'm not going to stop at any one particular place for very long at any point in the show because we have a long ways to go. So we're going to only stop very briefly at any particular spot. And I'm going to continue to zoom us away from our Earth, away from those human-made satellites that we have going around us. And our first stop is going to be our closest natural satellite, the Moon. Now, when I change focus over to the Moon, sometimes it does it rather quickly. So if this makes you dizzy, close your eyes for a second. Ooh, yeah, that was pretty quick today. So we're going to fly over to the Moon. And the Moon is as far as humans have traveled out into space so far. So already we've hit a milestone here with our human influence out there in space. Our closest natural neighbor is how far we've gone. The Apollo astronauts came out here about 50 years ago. And even though it is our closest neighbor, it's still about 250,000 miles away from us. And when the Apollo astronauts visited, it took them a couple of days or so to get here. And as we go farther and farther today, we're going to see amazing distances of millions and billions and sometimes trillions of miles and kilometers. So at the Moon is where I like to introduce an idea that I'm going to be using throughout the rest of the show. I'm not going to use miles or kilometers or anything like that to tell you how far we've gone from here on out. Instead, I want us all to imagine that we are traveling at the fastest speed we know of in the entire universe. Imagine that you can travel at the speed of light, so fast that it's hard for our human brains to even comprehend. If we were traveling at that incredible speed, it would take us about 1.5 seconds to get to the Moon from Earth. So we say the Moon is a distance of 1.5 light seconds from us. Or the time to travel here, traveling at the speed of light, would be about the same as the amount of time it took us in OpenSpace today. And I do want to point out something kind of cool. So we are seeing where the Moon is around us right now. You can see the Earth over there on the bottom left. We are right now seeing the far side of the Moon. This is the side of the Moon that we never get to see from here on Earth because it's always facing away from us. So you may notice it looks a bit different from the side that we normally see up in the sky. A lot less of those dark Maria areas. But again, let's keep on going because we have a lot of other stops to make as we zoom out into space. So as I zoom away from the Moon, I'm going to bring up now some blue lines so we can keep track of some of the other objects in our solar system. So we're seeing here the orbit of the Moon where it goes around our planet, but we're also seeing the orbits of the other planets in our solar system and where they go around the sun. So I'll focus for just a moment here on the very center of our solar system, the closest star to us, the sun. And think once again about that light speed. So if we were traveling at the speed of light, it would take us about 8.5 minutes to get to the sun from Earth. So the sun is about 8.5 light minutes away from us. Oh, sorry, that was kind of fast. Sorry about that. Didn't give you a warning that time. So there's a couple of ways I like to think about that. One way to think about it is that if the sun just disappeared for some reason, we wouldn't know about it for 8.5 minutes. But don't worry, the sun has no reason to just disappear, so we don't have to worry about that too much. Another way I like to think about it is that if you walked outside today and you looked up at the sun, don't do that, first of all. That's really bad for your eyes. Never look at the sun. But if you did look at the sun, that's how the sun looked 8.5 minutes ago, not how it looks right now. And within these few light minutes of distance, we can see the orbits of the closer, rocky, smaller planets in our solar system: Mercury, Venus, Earth, and Mars. And you can see there's a pretty sizable gap here in between Mars and the next planet, Jupiter. But that's not totally empty space. That's where we see a lot of the smaller, rocky objects in our solar system, which I'm going to make much brighter than normal so we can see them, where we find the asteroids in the asteroid belt in between Mars and Jupiter. though not all of the asteroids are in between Mars and Jupiter, just most of them are in this area that we're seeing here. But beyond the asteroid belt, there's Jupiter, and then we've got the next planet Saturn, and farther out still, Uranus and Neptune. Now, I currently only have the planet orbits up, but I am a big fan of also talking a bit about what is my favorite dwarf planet, and I'm sure is a lot of people out there's favorite dwarf planet, Pluto. And here's the orbit of Pluto out here, which I'm going to toggle on and then toggle off for a moment. We're going to fly over to Pluto real quick because I like to visit it. And as I fly over to Pluto, I want to talk a little bit about why we don't call it a planet anymore and why we call it a dwarf planet. Now, this has been true since 2006. Ever since 2006, officially, Pluto has been called a dwarf planet. But several years later, we had a spacecraft visit Pluto called New Horizons. It flew very close to Pluto and took some amazing high-resolution images that we're going to see in just a moment as we fly up to it. And because of that, and also just because of a lot of us learning about Pluto being a planet for many, 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 many years, people were confused about why it was changed to a dwarf planet. And to this day, working in the planetarium, I often get questions about Pluto. People ask me, what happened to Pluto? Did it explode? Is Pluto still in our solar system? Why do you hate Pluto? And I'm here to tell you I don't hate Pluto. I think it's beautiful. Look at all these wonderful features that Pluto has. It has this large, kind of heart-shaped area, the white area we're seeing in the middle there. There are ice mountains that it has made of water ice. It has nitrogen snow. We think that perhaps under this white area here, there's a slushy ocean or lake of some sort. It has a thin blue atmosphere. So it's a very, very interesting place. But we didn't know a whole lot about Pluto in detail until New Horizons went out here back in 2015, so not too long ago. But even so, as we did start to learn more and more about Pluto and learn how interesting it is, how many different cool features it has, still, we do call it a dwarf planet. We are still not calling it an official planet. And that's because what we determine to be an official planet, one of the requirements has to do with where that object orbits. So if I zoom back out and show us the orbit of Pluto once again, let's put on its orbit right there. There we go. You can see it way out here in the solar system. And I'm going to bring up some other trails of what we call the Kuiper Belt, or also trans-Neptunian objects, objects that orbit really far away out beyond Neptune. Now, if you take a look at these, first of all, there's quite a lot of them, so it's a little jerky as I try to rotate around. But if you take a look at where these objects are orbiting, a lot of them orbit around the same area as Pluto. And astronomers started to find more and more of these in the late 90s and early 2000s. And as they did start to find more and more of them, they found a few around the size of Pluto, and just more and more as they kept looking with our better telescopes that we started to have. So instead of adding on, say, a half a dozen or so more planets, people kind of took a step back and decided, let's come up with another category of these objects that have a bunch of stuff in their orbits, but they're bigger than smaller rocky things like asteroids. So throughout that process, Pluto was changed to a dwarf planet, but it is the biggest dwarf planet in our solar system, which is kind of fun. And we got to learn a lot about it, even though it is in this different category than the planets. So no need to feel sad for Pluto, in my opinion. It's still a very, very cool place. And speaking of the New Horizons spacecraft that went out to Pluto, I'm going to show you where that is and how far it's gone so far, as well as a few of the other spacecraft that we have sent out into our solar system. And these are showing the spacecraft that we have sent out with the intention and the purpose that they will leave our solar system behind entirely. So these are some of the farthest and the fastest spacecraft that we've sent out so far. Pioneer 10 and 11, Voyager 1 and 2, and New Horizons, which went out to Pluto. But even so, even though these ones are going incredibly fast and they've gone incredibly far, we haven't yet got out to a distance that light could travel in a day yet. So we were talking about 1.5 seconds if we were traveling at the speed of light to get to the moon, the farthest that humans have traveled, about 8.5 minutes to get over to the sun. And out here, we're out to several light hours of distance, but still not quite out to light days. And as we continue to zoom away from the Earth and from the sun, we're in kind of a strange area here where it's a little hard to tell exactly where our solar system begins and where our solar system ends. Because there are a lot of things going around the sun. There are the planets, the asteroids, there's comets, there's gravity that the sun has, it has a magnetic field, all sorts of things. And with all of that combined, it's a little tricky to figure out, okay, where does this solar system begin and where does it end? But you may have noticed that the sun just got a different look to it. I was dimming down the sun before, so we were able to actually see the other objects in our solar system a bit better. But now we've adjusted our OpenSpace model here so that the sun is at its true brightness. So if we were really able to fly out this far, this is how bright the sun would look compared to the other stars. And if I keep on going, go ahead and take a look around us as we zoom away from the sun. And you'll notice that we are starting to fly past some other stars. So once we're this far away, and once we're starting to see other stars as we fly out, there's no question whatsoever at this point. We are outside of our solar system, and we are now in what we call interstellar space, the space in between stars. And if we're going to check in with how far we've gone at this point, so the edge of where any of those spacecraft we've sent, the farthest spacecraft, that was about a light day or so roughly. Now we're up to a few light years. If we were to travel from the sun to the closest star to us, Proxima Centauri, it would take us about 4 years if we were traveling at the speed of light, the fastest speed we know of. And as we continue to fly past these other stars, I do want to bring up something that we've learned a lot about in the recent years, in the last couple decades or so here. So we've learned a lot about the things in our solar system, the smaller objects in our solar system, like over by Pluto in the last couple decades or so. But also we've been learning about things out here around other stars. I'm going to bring up some blue circles to show us where there are planets, what we call exoplanets, planets that are outside of our solar system. Every single one of these blue markers is showing you where there's a star that we have found at least one planet going around that star. And many of these stars have multiple planets going around them. And the first exoplanet that was discovered was back in 1995. So we've only been finding these for about 25 or so years now. But even so, we're up to over 4,000 exoplanets that have been found, and thousands more that we call candidates. Places that we think are exoplanets, but it's going to take a little bit longer to watch them as they're going around their parent star to make sure it is in fact a planet and not some other object like maybe a sunspot or something like that. And right around here is going to be the last time that we can check in with our human influence out here in space, because we already saw a while ago how far our spacecraft have gone, but now we can see the last thing that we've sent out into space, the farthest it's gone, are radio signals. So since the 1930s, we've been sending out radio signals that are strong enough to escape our planet. So about 90 or so years, we've been sending out some radio signals out into space. And those radio signals are all traveling at the speed of light. And out here in space, as long as you don't run into something, you're just going to keep on going exactly the same speed that you started with. Nothing's going to slow you down. So if those radio signals kept on going without running into anything, that's how far they could have gone. That little sphere there, what we call the radiosphere. So everything we're seeing from here on out, this is not because we've sent anything there. It's not because we've sent a spacecraft or a probe to go and take a picture. All of this is because the light of these objects has traveled to us, and it's gotten into our telescopes and we're able to see it. But we're going to keep on going. We still have a long ways to go, even though we've reached the edge of our human influence out here in space. And I'm going to turn off the exoplanets, but I'm going to keep on the radiosphere. See if you can keep an eye on it as we fly away farther and farther. And you may notice we're kind of seeing a shift happening in our model here. So we're seeing the individual stars that are closest to us, where we mapped out those individual stars, ones that you're likely to see if you go out stargazing at night. But in a moment, we're going to see a different kind of model of the galaxy that we live in. So this is not based on exactly what we've seen or taken images of. It's based on what we have seen and also our best guess based on what's outside of our galaxy. Because we have not traveled this far out, so unfortunately, we haven't been able to go outside of our galaxy and snap a picture. But based on the stars and the gas and the dust and such that we do see from where we're at, and based on other galaxies we see, we're able to put together this model of what we think our galaxy would look like if we could, in fact, fly out this far. And let's check in again with how far we have gone. We've made quite a jump here once again. So can everyone still see the radiosphere? Yeah, that little blue dot on the left there, that's how far our human influence has gone, about 90 light years in every direction. And it looks teeny tiny because our galaxy is gigantic. If we wanted to travel across our galaxy from one side to the other, it would take you about 100,000 years if you were traveling at the speed of light. And within that 100,000 light years, there are billions of stars. And perhaps billions of planets too. We think a lot of those stars, or maybe all of those stars, have some exoplanets around them. But we still have even farther to go, so we're going to keep on going. And now that we're zooming away farther from our galaxy, we're starting to see a lot of other dots showing up. Now, these are no longer individual stars like we were seeing before when we were closer to the sun. Now, every single one of these dots is another galaxy. And every single one of those galaxies has its own billions or sometimes even trillions of stars. Now, if you're curious about the colors of these are not the colors of these galaxies. I'm sad to say. I do think it would be fun if it looked like cosmic Skittles out there in the universe, but no. We've color-coded these galaxies so we can remember what groups they're part of. So things like some of these galaxies, they're part of certain groups and clusters of galaxies. So sometimes we'll categorize them based on that. Or we'll also put them into different groups depending on what survey was used to find them. So basically, what group of people or what telescope was used to discover these galaxies. So these are an actual map of where these galaxies are relative to us. So these are ones we've seen with our telescopes, either here on Earth or the telescopes that we have out in space. But because this is an actual map, and this is what we've seen so far, at a certain point, it's going to look really strange. Right around here, we're going to see an odd shape that these galaxies seem to form. Let me see if I can get us a good angle here. It's going to look sort of like an hourglass or a butterfly or a bow tie, something like that. I am once again sad to say the universe is not shaped like a butterfly, though I do think that would be nice. This shape we're seeing is because of where we are in our perspective here on Earth. So these gaps that we're seeing on the left and the right, when we try to look over in these directions, we're having to look in the same direction of our galaxy, the Milky Way. So we have a lot of stuff in our galaxy: gas, dust, stars, planets. And when we try to look over in those directions, our galaxy is blocking our view. So we think there are just as many galaxies over in the direction of those gaps, but we just haven't been able to map it out as much as the galaxies you're seeing on the top and the bottom. And we don't have a whole lot farther to go. There is an edge to everything we can see in our entire universe, but I do want to check in real quick, see how far we've gone. So the last we checked in, if we were to go across our galaxy, the Milky Way, that would have taken us about 100,000 years. Way out here, now that we're seeing this interesting shape of our map of these galaxies, we are billions of light years away from the sun at this point. And something that's really cool about that is that we're kind of time traveling in a way, because this light takes so long to get to us that by the time it travels all this distance and it gets into our telescopes, we're seeing the light of these objects as they were in the past, not how they look right now. So if you recall, near the beginning of the show, I mentioned how if you look at the sun, again, do not do that. Don't look at the sun. But if you were to look at the sun, that's how the sun looked 8.5 minutes ago, not how it looks right now. Well, this is what our universe was like billions of years ago, not how it is right now. And because of that, in a moment, we will have reached the edge of everything we can see in our entire universe, the edge of our observable universe, it's sometimes called. And that edge of our universe that we can see is called the cosmic microwave background, all over the dome now. Now, when you walk outside at night and you look up at the sky, you're not going to see this everywhere you look. Thank goodness, that would scare me. But if you did walk outside at night and you were able to see microwave light, a lower energy form of light that our eyes can't see, but some of our telescopes can, then you would see this every single place you look in the sky. And this is light that was around a few 100,000 years after when the Big Bang would have happened, when it was first able to just kind of spread out and go around in all directions. So I like to think of this as the baby picture of our universe, the earliest light that we can see. But since this is the earliest light, that means I can't take you any farther. So we're going to end our journey today by flying back home. Now keep in mind, if we were really this far away in space, and if we were really traveling at the speed of light, this journey would take us about 13.5 billion years. But thankfully, we're in the planetarium. It should only take a couple minutes. And as we zoom on back home, one last thing I like to leave folks with is that all of this that we've been looking at, all of these stars, galaxies, planets, cosmic microwave background, gas, dust, all the stuff that we can see, is a very small part of everything we know to be in our universe. There are mysterious things that we call dark energy and dark matter. Dark energy is some mysterious force that is causing space itself to accelerate as it expands. Dark matter is some mysterious substance that doesn't seem to interact with light at all, but we see evidence of it a lot of different places, especially at the edge of galaxies. And while we're not quite sure exactly what these things are, we do know that they make up about 96% of our entire universe. So all this that we can see is a teeny tiny part of everything out there. And I know that that can make folks feel pretty small and kind of uncomfortable. And I agree, that makes me feel kind of small and uncomfortable sometimes too. But another way I like to think of it is that, well, yes, we are this teeny tiny dot in this gigantic universe, but look at all of this that we have found so far, almost entirely by just looking through telescopes. And there's a whole lot more to discover and a whole lot more to learn about out there. And that's pretty exciting. But even so, I do always have a little bit of a sense of relief when I see that radiosphere and we start to approach our human realm of the universe once again, as we've got about 90 light years left to go. And in a moment, we'll see the sun start to approach us as we get closer, that closest star to us at the very center of our solar system. And we're going to head past those farthest spacecraft that we have sent out into space, back over to the third planet from the sun, the only place in all of this that we have found life at all so far, which I also think is pretty incredible to think about. And we're back home. Hooray! So with that, I want to thank you all for joining me today for our tour of the universe. I hope you enjoyed our time as we flew around in space together, and I hope you all enjoy the rest of your day. Thank you so much for coming.